Good afternoon, my YouTube viewers. Crystal here. I wanted to make another video for you, and I wanted to carry on with my analysis of the COV19 new cases and new deaths. Now, what I wanted to analyze today is I wanted to analyze the UK, South Africa, and Nigeria, because these are the three countries that a strain of the original virus has mutated from. So now what we have is we have a situation. We have the original virus that is believed to have come out of China, and then that virus has mutated into three strains coming out of UK, South Africa, and Nigeria. So I wanted to analyze these because I thought it would be a good exercise to see how these different strains are affecting the population. So the first thing that we did is we used the CSV data file from our World in Data website, and you have to download this CSV data set every day because it is updated every day. And if you want to have if you want to work with the most current information, then you have to download it every day. So I have downloaded it onto my Google Drive every day that I have been working on this CSV file. But one thing that I will say is I don't think that the CSV file is very accurate in some respects, and I'll tell you why later. So I wrote this program on Google Colab because Google Colab is a free online Jupyter notebook, and it has a lot of the libraries already installed on it, and so the only thing that you have to do is import them. So what I did was I imported pandas and NumPy. So NumPy is a numerical library, and pandas is written on top of NumPy. I found that out just last night when I was doing some studying. And I do study, but I prefer to write programs because when I write a program, I can make a blog post on it, and then I can put the blog post on the Medium website and get paid for my work. But I don't get paid very much. It's just pennies, really. So the first thing we do is we read this data set, and if you'll notice that a lot of the data set is not current in a lot of aspects, and I'll go over that with you. And this is the data set for the whole world. But you'll see we've got like new cases smooth, you got null values, total cases null values, new deaths null values, new deaths smooth null values, total cases per million, new cases per million, and then new case smooth per million, null values, total deaths per million, null values, new deaths per million, null values, new deaths smooth per million, null values, reproduction rate, null values, ICU patients, null values, ICU patients per million, null values, hospital patients, null values, hospital patients per million, null values, weekly ICU admissions, null values, weekly ICU admissions per million, null values, weekly hospital admissions, null values, weekly hospital admissions per million, null values, new test, you've got some null values, total test, null values, total tests per 1,000, null values, new tests per 1,000, null values, new test smooth, null values, new test smooth per 1,000, null values, positive rate, null values, test per case, null values, test units, null values, total vaccinations, null values, total vaccinations per 100, null values, stringency index, null values, population, they did get that right, population density, they did get that right, Medium age, they did get that right. Medium age 65 and over, they got that right. Age 70 and over, they got that right. GDP per capita, they got that right. Extreme poverty, null values. Cardiovascular death rate, they got that right. Diabetes prevalence, they got that right. Female smokers, null values. Male smokers, null values. Hand washing facilities, they got that right. Hospital beds per 1,000, they got that right. Life expectancy, they got that right. And Human Development Index, they got that right. So we've got a lot of null values in there. And so I could actually do a lot more research if there wasn't so many null values, like hospital admissions. That would be a good thing for me to investigate. But since hospital admissions, they're not filling that in, I can't investigate it. I mean, there are other places where I can look. So, like in the UK, you got like NHS England, but you don't have NHS UK. So you'd have to find NHS for England, Scotland, Wales, and Ireland. And then you'd have to combine all of that to come up with NHS UK. And I still haven't found out where I can find that information yet. So I'm not going to do anything about that at the moment. So going back to the code review, after we loaded our data set, we want to find out what this file is composed of, which we've already gone over what the file is composed of, but it's mostly floats with a few objects. And so the next thing that we want to do is when we predict upon this model, the model is not going to accept a date. So we have to convert the model to a number. So what we've done is we've imported date time, and date equals train date equals PD to date time, train date errors equals coerce, train date num equals train date DT strf time, format, and then train. And then so what we'll do is we'll come over here and we'll come over to the very end of this data set. And you can see we've got a new column called date num, where the date has actually been converted to a numeric value, because that's what we want to do. We want to convert everything to a numeric value. And that's what we did. And the next thing we do is we want to find out which countries are in this data set. So we use special coding to find out which countries are in the data set. So country equals train.location.toList, and list equals country, and the country's blank. For I in country, if I not in list country append I. So basically what that means is if the country is not already in the list, then you can append the country to the list. And so we've got 192 countries in that list. So what that means is one of the countries has dropped off, but I don't know which country has dropped off. Now what we want to do is we have to manipulate the dates. And the reason why we have to manipulate the dates is because we have to use the dates to determine, to filter out which information we want to see. So we import date time date, and we import date time delta. So today equals date today. And so that's 2 January 21. Yesterday is today minus time delta, days equals 1. So yesterday is 22 January 1st, 2021. Last month equals train date max. And so what we're doing is we're finding the maximum date in the data set. And so we print off last date, we find out it's a timestamp. We print off and then we timestamp yesterday. We print that and we find out that's a timestamp. And now we're going to use an if, elif, and else statement. If last date equals yesterday, last date equals yesterday. If last date greater than yesterday, last date equals yesterday. If else, last date equals last date. And then you print off last date. And so what we do is we timestamp. It's timestamped when we print it off. And so now what we want to do is we want to print off, we want to filter out the data set and only print off the data for last date, which was January 1st, 2021. And that's going to come in useful later on. And now we do a graphical representation using Matplotlib. So we graphically represent new cases, and then we graphically represent new deaths. And now what we do is we look at the location. We want to see the new cases in comparison to the location, so you can see that. But because it's 191 or 192, we can't really make out what the location is, but you can see it. And then we look at the new deaths per location as well. But since it's 191 or 192 countries, it's going to be hard to determine what the country is. Now what we do is we do a box chart based upon the continent. So you can see that we have the most cases in the continent of North America. And then we do a box chart on new deaths, and you can see that we have the most new deaths on the continent of North America. And now what we have is we have a heat map. So if you like looking at heat maps and you want to see how the different independent variables relate to the dependent variables, then you can see that for yourself on the heat map, and you can interpret that for yourself. And now what we're doing is we're filtering out all of the countries that we want to look at. So I've been using this program for a while for quite a few countries. So it's got quite a few countries in it. But the first country that we filter out is the UK. But while we're in the UK, what I want to do is I just want to go through a quick check and see what all is missing. So we've got hand washing facilities. That's information is not available. Mills. Total vaccinations per 100. Information's not available. Total vaccinations. Information's not available. Test units. A lot of that information is not available. Tests per case. A lot of that information is not available. Positive rate. A lot of that information is not available. New test smooth. A lot of that information is not available. New test smooth. New test thousands. Total test per thousands. Total test. New test. Weekly hospital admissions. Weekly ICU admissions. Weekly ICU admissions. Hospital patients per million. Hospital patients. ICU patients. Reproduction rate. All that information is not available. So I could do more research if they actually put the information in the data set. But because they're not putting the information in the data set, I cannot research this information. So we've got the new deaths per million, and then we've got the new cases per million. So yeah, so basically if they updated the data set with all the information that they say that they can use, then we could do lots of research. We could do research on hospitals. We could find out how many people are admitted to the hospitals, because from what I understand at the time that I'm making this video, there's a lot of admissions to the hospitals, but I've got to find out how I can get that information for the different 4 countries in the UK and combine all that information so I can use it in this analysis. So that's just some problems that we have. And that's the problems of a data scientist, because quite often the information they have is not accurate or not enough or not current. And you can see here for yourself that a lot of the information isn't current. So now what we're doing is, this is the new cases as of yesterday, and you can see that the new cases in the UK have just been spiraling upward, and this is most likely due to the new strain of the virus that's a lot more virulent than the original strain. And now we've got new deaths, and you can see that the new deaths are just spiraling upward as well, and that's to do most likely with the new strain. Now we're looking at the United States. I'm sure that the United States information is very similar to the UK's, but we can have a little look at the file and see. Yep, hospital admissions, things that I could be looking at, hospital admissions and hospital patients. That information, would come in handy, and I could analyze that information if it was current. I mean, I can give it a try, see if I can use it. But if they do not have all of the information, there's not a whole lot I can do, but I can always give it a go. And so we've got new cases per million. You can see that's creeping up, and that's probably due to the mutations. New deaths per million, that's creeping up, and that's probably due to the mutations. And now we've got China. So China's information, in my opinion, is not reliable, because they're saying now that they don't have any new cases, or they have very few new cases, and they have very few deaths. And so I just think it's not reliable. So you can see here's their new cases per million, and you can see here's their new deaths per million. But because of their government, I really wouldn't put a whole lot of stock into it. And the next thing we have is Taiwan. Taiwan is pretty much the same situation. Here's their new cases per million. It's creeping up there. Well, it's stable, really. And they've got their new deaths per million. But basically, their rates are actually similar to China's rates. But the thing is they're saying that because they're clean and because they have early intervention and trying to tackle the virus, that they haven't got the virus in their country so much anymore. And so these countries that don't have a lot of cases of the virus, they've always got an excuse as to why they haven't got the virus. So now we're looking at South Africa. South Africa has a variant of the virus in it. And so you look at the new cases, and you can see that the new cases are spiraling up, because there is a new variant of the virus in South Africa that's more contagious than the original virus. And you can see the new deaths, and you can see the new deaths are spiraling up as well, and it's probably to do with the new variant. Now we're looking at Nigeria. Nigeria has a new variant of the virus as well. So we're looking at the new cases of virus, and you can see that the new cases are spiraling up. And look at the new deaths. The new deaths are stabilizing. Now we're looking at Sweden. Okay, now Sweden didn't have a lockdown, and because Sweden didn't have a lockdown, their new cases are going up. And because Sweden didn't have a lockdown, deaths caused by the virus are going up as well. Now we'll look at Denmark. Denmark is a neighbor of Sweden, and Denmark did have a lockdown. They had a lockdown very early on, and because they had a lockdown very early on, they didn't have so many cases at the very beginning, but now the cases are creeping up, and that's probably to do with this variant, this mutation that's coming out of the UK, because UK is not that far away from Denmark. And the same thing as the deaths. They had a lot of deaths in the beginning, and then they were able to get it under control, and now they're having more people die from the virus, and that's probably to do with this mutation that is very contagious. Now what we're going to do is we're going to look at the new cases. We're going to compare the new cases to the deaths, so you can see that the new cases are a lot higher than the deaths. And we'll look at the new case that was in the UK, I believe. Let's look at this. This was worldwide. This is worldwide. So the deaths are a lot less than the new cases. Now we're going to look at the US, and you can see that they have a lot more new cases than they do deaths. And you can look at the UK. They have a lot more new cases than they have deaths as well. So now what we're going to do is we want to compare all of these countries, but the only countries that we're comparing in this particular program are the UK, South Africa, and Nigeria. And the reason for that is because these countries have the mutation. And since they have the mutation, what we want to do is we want to look and see how the coronavirus is spreading in those countries. So we'll look at the UK. We had to take off the first 28 rows to make the UK compatible with the other countries. We take off the US. We had to take off the first 37 rows to make the US compatible with the other 37 with the other countries. We look at the China. We had to take off the first 37 rows to make China compatible with the other countries. We look at Taiwan. We had to take off the first 43 rows to make this data set compatible with the other countries. We look at Sweden. We had to take off the first 27 rows to make this data set compatible with the other countries. And we look at Denmark. We had to take off the first 32 rows to make this data set compatible with the other countries. Look at South Africa. We had to take off 21 rows to make this compatible with the other countries. And so now what we've done is, since we've had to take off all of these rows of these data sets to make them compatible, now what we've done is we've created a variable called date, which is the values of revised UK COVID-19.date. And then all of the other data sets, we've created variables for new cases per million and new deaths per million. And these variables are going to be used to make data frames for every country. So you see we've got a data frame for the UK, that's UK compare, we've got US compare, we've got China compare, Taiwan compare, South Africa compare, Nigeria compare, Sweden compare, Denmark compare. And now what we have done is we have merged all of these data sets together to form one large data set. And next thing that we have to do is we have to check to see if there are any null values. And so we do have null values, but those null values are in numeric columns. So what we've done is we've replaced all of these null values with 0, because I didn't want to replace the null values with median, because I just thought, well, that's not really going to work out. Now, if I really had wanted to, what I could have done is I could have used the iterative imputer to do that, but not sure that would work out either, because I've got the date column, which is an object column. So now what we're doing is we're getting to the actual analysis, which is what you want to see. So we're comparing South Africa, Nigeria, and the UK. The UK is green, so you can see that the UK has the most cases, and that's to do with this new strain that's a lot more contagious than the original virus. And then you got South Africa, which is blue, and so you see that we had a spike of new cases, and then it tapered up, and now the new cases are going up again, and that's because South Africa has got its own mutation. And then you've got Nigeria, which is a really low level. Now, I looked it up, and I'm going to put it in my blog, but Nigeria is just saying that the reason why they have so few cases of the virus is because of the age of the people they're able to fight the virus off. That's the excuse that Nigeria is giving. So let's just come back here to Nigeria's data set. We're just going to look for Nigeria's data set very quickly. So here we are in Nigeria, looking at Nigeria's data set, and let's look at the average age of the typical Nigerian. The average age, or the median age, of the typical Nigerian is 18 years. So the typical average age of a Nigerian is 18 years old. And so what we can do is we can look and see what we've got. What's the average age of someone from the UK? So I think we're in the UK now. So let's just look at the average age of someone from the UK. Median age is almost 41, 40.8. So it's almost, we'll say the median age is close to 41, which I'm older than that. Never thought I would get this long, but I'm older than that. And now let's go to South Africa. See if we can find South Africa. Let's look, see if we can find the median age of someone in South Africa. Median age 27.3. So in UK, you've got a median age of close to 41. South Africa, you've got a median age of 27. And Nigeria, you have a median age of 18. Let's see what the median age of China is, even though we're not analyzing it. It'd just be good to see what their median age is. 38.7. So the median age in China is less than the median age of the UK. So the UK has the highest median age. So it's the UK, then it's China, even though they're not being analyzed. Then it's South Africa, and then it's Nigeria. And so Nigeria is basically saying that because of the age of the people who are getting the virus, they're able to fight it off. And so their median age is very young. So that's the reason that they're giving, that they're not having a lot of cases. And it's the same with the deaths. So if you go back and look at the deaths, the UK is green, and they started out with a lot of deaths in the beginning, and then they didn't have any deaths. And now the deaths are creeping up or escalating up, and we believe that's due to the mutation of the virus. And then you've got South Africa that had a lot of deaths around the middle, and then that lowered, and now their deaths are creeping up as well, and that's probably due to their own mutation. But even though there is a mutation coming out of Nigeria, Nigeria doesn't show that the mutation is affecting their new cases and their new deaths. So we've completed the analysis of UK, South Africa, and China. But since we're in the computer anyway, what we'll do is we'll go ahead and finish this code review, because I did some more work on it yesterday or today. So we're going to check the train file for null values. We've got loads of null values. And what we did was we did a filter, and we filtered out all of the categorical columns, and all of the categorical columns that had null values, we just filled it with the section that said not listed. And so that just created a new category. And then after we created that section that was not listed, what we did was we imputed all of the null values with 0, because I didn't want to say median, because we didn't know what the median was. So I just put 0 in there. All of the categorical columns, we put them on an ordinal encoder, and what that did was that transformed it to a number, because that's what the model wants to see. The next thing we do is we define our X and our Y values. We created a variable called isocode, which means train.isocode. Y value is train.newdeaths, and X is the train with lots of columns dropped. And you can see for yourself all the columns that have been dropped. And now what we've done is we've taken X and we've put it on a standard scalar. So you can see Y, and then you can see X. So X is an array because it's been put on a standard scalar. Now what we're going to do is we're going to split our training set using the function called train test split, and we're going to have a validation set of 10%. Next thing we want to do is we want to select our model, and basically what we're going to do is we're going to use the hist gradient boosting regressor, because this is a model that's been designed for large data sets, and we've got a large data set. We had an accuracy of 99.50% using this model. So we have predicted on our validation set, and we got an 89.86% accuracy when we have predicted on our validation set. And so what we've done is we've created a little chart, and the chart doesn't look very well, does it? But it does allow you to compare the validation set against the prediction. And then we put the validation set and the prediction on a data frame, so you can look at the validation set and the predictions and compare them. And so now what we're going to do is we have to create a new data set that's called test. So at the beginning of the program, these dates that we manipulated are going to be used to create this test data set. So test equals last date dot copy, test date equals today, and then text. So you can see that the date is today's date. But if you come over here to the end of the data set, you'll see that the date num is still yesterday's date. So now what we have to do is we have to take the date and we convert it to a number. And when we have taken this date and we have converted it to a number, you'll see that today's date is now being converted to a number. So what we want to do is we want to check for any null values, and what we're going to do is we're going to use exactly the same process that we used with the trained data set. We're going to impute the missing values. We're going to drop the date. So predict date equals test date, and then we drop the date. And now what we're going to do is we're going to filter out all of the object columns. And then when we have filtered out all of the object columns, any of the object columns that have missing values, it's just going to be filled with the words not listed. And what that will do is that will just create another category. So now that we've replaced all of the object columns with not listed, now what we can do is we can impute the numeric columns. And what we're going to do is we're just going to replace all of the missing values with 0. So now we've got test, and you can see that the test columns, the categorical columns will say not listed if it's a missing value, and it will just say 0 if it's a missing value and it's numeric. So now what we're going to do is all of the categorical columns, what we're going to do is we're going to replace those categorical columns with numbers by using the ordinal encoder. Now what we're going to do is we're going to define xtest. So ISO code equals test.iso code, and xtest is going to be exactly the same format as x. And we're going to have to drop a lot of columns to make it do what we want it to do. Then we're going to take xtest and we're going to put it on a standard scalar, and you can see xtest is now an array. And now after we've done all of this pre-processing, now what we can do is we can predict on the xtest. So we're predicting on the xtest, and we put it on the data frame. And then if you want to, you can check tomorrow to see how accurate the predicted values are against the actual values tomorrow. So that pretty much concludes this code review. It was a bit of a long program, and we spent a lot of time talking about it, but it was good to go over this code review to look and see if we've made any mistakes. So I think that concludes this video. If you like my video, please like, subscribe, and share. If you like the work I do and want to make a donation, I have my email address to my PayPal account in the description box down below. And I will be making a blog post on the work I've done, and that will be my next video. And in the blog post, I will have the link to my GitHub account. So if you want my GitHub account, then you need to read my blog post, which will be coming up next. So thank you very much for watching my video, and I look forward to making new videos for you in the future.